Well, hello everyone. So there was a discussion about splines, hair, and all sorts of things, including the email, uh, the email thread, and a post on the Reddit forums. And I thought I'd give you some insight on, if not to solve the whole problem of vertex maps and vertex colors to render splines in Redshift, which apparently isn't possible now, but some other ways using some simple nodes to do various types of colorization. So I have the beautiful 1.1 million point spline themadoodle here. And what we're going to do, we've set our renderer to Redshift. And first of all, I want to show you what won't work and just to curb your expectations. And then I'm going to show you how to do things so that they work. I just want to waste your time. That's why I'm starting with what doesn't work. So we have a spline, and by definition, it doesn't render. We know that. I have a dome light, just a white dome light here. Now, some people may assume that if I right-click and go to the render tags and add a Redshift object and set this to hair strands, that we can start using it. Now, you can use it to a certain extent. And I'm just going to wait a couple of seconds, extracting geometry. So we do get this, and it works with thickness and so forth. And on this particular object, we can go and add some sort of material to do various things. So let's go and create a Redshift standard material. And let's drag it on this. And let's open the material. I'm going to close this because these are quite a few. There's a high number of points here, and it will slow things down. So let me turn this off. Good. And you can see that the material has been applied here. And let's go over here. And I'm going to make some space so we can see what's happening. And let's go and add a ramp and get a ramp here. And let's put it in the color of the standard material. And let's render this and see what happens. Now, usually these ramps and all that, and most things are done using the UV coordinates of the object. And you will see that we get this fairly odd result because we don't have a robust way to define the size of the texture here. So I just think that what you see here is just an artifact of the UVW. I think for hair strands, the U is the length of it and things like that. Now, you can always go here and look for the hair position. And the hair position will read from the parameters the U or the V. And you can potentially put this in a standard material and get some colorization. But the problem with this particular set of splines is that some of them go from inwards outwards, but some of them go from outwards inwards. So although you have a gradient in the V direction, that gradient doesn't represent the inner part of the splines and the outer part of the splines. They don't all have the same, let's say, winding direction and so forth. So you're going to have certain problems to create some, let's say, controllable colorization for this because you have no control over the U and V coordinates of the spline itself. So we are going to scrap this for now, and I'm going to show you what is the way to have a bit more control. And for that, we are going to predominantly go to the hair material, the actual Redshift hair material, which is this one over here. Now, this node, the C4D hair attributes, reads whatever is in a Cinema 4D hair material. So it uses the color, the thickness, and all sorts of things, frizz, kink, and so forth. So for certain things, it's extremely good. But dropping this and then this on your strands actually won't produce any result. This works strictly with hair objects. But luckily enough, what you could do is you can select the spline, go to simulate and then hair edit. And there's this thing that says convert from spline. So what this is going to do, it's going to create hair strands, actual Cinema 4D hairs from the spline. So I can close this down for a second, and I like to turn it off before I close it down, just to make sure, paranoia always kicks in. So I've turned this off, and yet we see all these splines. And that's because when you run that command we did over here, the hair edit convert from spline, and you can do the opposite, convert to spline. It creates a hair object, and it links it up in a very particular way with the data. It's not connected to something, but it's read the data. This now contains the data for the splines. And some of them are, the roots are where the circle is, so some of them you have the roots here, some of them you have the tips here, and you can see those reverse windings. That's why these circles don't appear everywhere. Anyway, now that this is an actual hair object, what we can do to this is go and add a hair material, a standard Cinema 4D hair material. And this will allow this material here to do all sorts of funky stuff like frizzing and kinking and all that nice stuff over here. And if you drag this material that has these connections, what you will see happening is that the colors and various other attributes from the Cinema 4D hair material should propagate to a certain extent to the hair system. So let's go and see this. I'm going to add a gradient for the length of the spline. And the problem with it not showing very well is because it has specular, and the specular sort of overrides the color itself. But now you can see that we get this gradient along each and every one of the strands. Now we can further this technique because, again, it doesn't seem to be very controllable in this particular case. So what we could do is, first of all, we can get rid of this. That's not necessary. Now this will help with the thickness and stuff like that. So you can say the thickness now at the roots and at the tips are 1 for the roots, thicker at the roots. That's why these are thicker, and 0.1 at the tips. If you set these to equal, then your hair object is going to have these strands quite equal. And you don't need to add a RedShift object tag on these hairs. RedShift interprets this as strands anyway. So you can say that I want these to be thin, so both the roots and the tips have equal thickness. And if you want to add some variation in the thickness, you will basically just go and play with this little bugger here. Putting the extreme values, the larger and the smaller, and then just playing with this. But anyhow, it's a manual process. So the thickness is controlled by this, and the color is controlled by this. But you can see that the color is not propagating properly, and that's because I removed the color component from this. Essentially, if you click on hair, and you get the C4D hair attributes, this node here is what reads the hair material that's added to your hair object. So I can take the out color, I can go to my RS hair over here. I've got too many things on my screen, and these are the main parameters you can drive. So I don't want any internal reflection, so let me turn this off so we have more responsive. I want diffuse to be at 1 and nothing else. All right. If you want to add them, you can always add them, but I don't want any primary reflection, any transmission. I just want diffuse. And now if I drive the out color and put it in the diffuse, and let me just show you how you can expose the color here. You press Control or Command on your Mac, and it exposes this little thing. So this is diffuse color. The weight is at 1. And now we should get all these strands colorized along their length, using the colors I put here, which are the rainbow colors. And I think this is doing something. Let me just rewind this and wait for it. Wait for it. Oh, that's interesting. I was oh yeah, this is the hair material. Yeah, diffuse. Let me see why this is not working now. The out color, let me just open this and make sure that yeah, this is the out color, This is the hair material. I'm just pulling this on the other side of my screen. Let me turn this off and on again, extracting geometry. There you go. So sometimes you just need to shut down RedShift and turn it on again because it doesn't refresh. And now the colorization represents the gradient we've put here, and I think it goes from roots to tips or something like that. So now we have this set up ready, but I'm not going to use, and this is the punchline of this tutorial, I do not want to use the hair material. So I can get rid of it. It was just one of the options you can use to do certain things. What I want to do is read various positions. So to begin with, I'm going to create an equivalent to a spherical field. And the way this is going to happen is that I'm going to read the position of each point that the renderer is rendering. And this is generally one of the differences when you're using a render node system and you read positions and stuff like that, and some other system like a Neutron or other kinds of nodes, Espresso and so forth. And what it does is when it wants to render, let's say, this pixel over here, and it fires the ray and it hits one of the hair strands plus its thickness and this area here, you can actually find out when that ray is ready to render, what is the position of that point in global coordinates. And to find that, you need what's called a state node. And the state node is something that returns various values from each render hit point for every pixel of your render when it's rendering. And what we can do is get the ray position. So for each and every one of these strands and every position along these strands, we know from this what the position in the 3D world that was that point, that rendered point exists. Now, those points are in values of X, Y, and Z, whereas colors for RGB are from 0 to 1, right? 0 to 255, but generally 0 to 100% for each and every one of the colors. So we'll have to do some range mapping. Anyway, if I take the ray position and put it in the color, you will see a node gradient happening when this decides to render. So let me turn it off and turn it on again, and hopefully we're going to see this after it's done with this little pre-processing. We should see this. Come on, there you go, preparing, there you go. Now, these gradients are red for X, green for Y, and blue for Z. But because they are in arbitrary values, in order for me to expand this gradient, oops, I need to undo here, and let me navigate around so you can see the whole thing. You can see that the gradation happens in a very small part, and then just the color goes above 1. So, 300% red is still red. I want to make it so that I'm going to remap those values to a value that is equivalent to the size of this, because I want my, let's say, radial gradient, my spherical gradient, to encompass the whole object. So to do that, I just need to take these values and remap them. So let's, it's not remap, it's a range. So it's change range. And I need the vector change range because we have 3 numbers, RGB or XYZ. And if I close this, basically I'm going to put the ray position itself in the input and put this in the output. And we shouldn't see any difference here. And if we do, it's going to be insignificant. But what we really want to do is make sure that the minimum, which is 0, the center of the world, and the maximum, which is, in this particular case of the change range, they're both 0 to 1. The maximum range should be something that represents the distance of the center of the world to the extreme of our object, how far it is. And if I select this spline and go here, you will see that my object is about 112 by 123 by 167. Now, because this is the total size from side to side, I want half of it because that's the radius. So let's go and put approximate numbers similar to these over here. For the x, I'm going to put, let's say, 60. For the y, let's put 70. And for the z, let's put 80. And now you will see that the gradients is going to be much smoother from the center, because this is the world center, all the way outside. I just need to, for this to, send the splines to the GPU and all that good stuff. I'm waiting for the text to appear here. So again, I'm going to turn it on, I'm going to turn it off and on, and then I'm going to restart this, and hopefully it's going to run. I'm going to move this. Where do I move this? I'm going to move this. I'm going to put it over here so it's tabbed in here. And it's not updating. Yeah, it's just not updating. I'm not getting my text over there, the text that indicates that the renderer is rendering. But that's not a problem with the node setup. It's just a delay because we have a huge number of splines. Maybe I should have used something a bit smaller, but nonetheless, there you go. So now you can see these gradients are better. So this is the mathematical way of creating a gradient where each and every one of the three axes is gradiating the red for the x, the y for the z, and the blue. Y for the green and blue for the z. But what if you want a homogeneous sort of gradient that goes from white to black or black to white, and then you can just colorize that. So in that particular case, what we could do is convert these positions, just get one of the numbers of these positions, the x or the y or the z or something like that, and use that, or even the distance from the center. So there's something called the I can't type, vector length. And basically what this is going to do, it's going to take the position of each and every one of these render points, the hit points that the ray hits, that are used here in colors. And it's not going to measure the x, y, and z. It's not going to return these three numbers that we are converting into three colors, but it's going to return the length of it. So how far away it is from the center. And that essentially will give us a black and white gradient. Any of these points that are closer to the center are going to have a smaller length. Anything that's further from the center is going to have a bigger length. So I'm going to take this ray position and put it in the length. And I'm going to take this length and put it, and I think in this particular case, because we're not changing the range of a vector, but now it's a real number, I'm going to type range again. I'm going to just take a normal change range. I'm going to do the same thing, but now it's only one number you have to deal with. So I'm going to make this 80, which is the biggest one, the biggest radius. You can make this as small as or as big as you want to create a gradient with this radius. And I'm going to take this and put it over here. So we should get a black and white gradient now. So let me turn this off, wait for 5 seconds, turn it on, and then refresh. It's not doing me the favor. I'm going to wait for it. It's probably doing something internally. Do it again, turn this off, wait a bit, turn it on. There you go. So now we have this. We have black to white with a radius of 80. So let me go here and sort of navigate around so you can see it a bit better. Now, the great thing with this setup is that now what you can do is you can go between this one. We don't need this, but anyway, just leave it there. Between this one, and you can add a ramp. So I can remap the black and white to any gradient I want. So let's put a ramp. Let's put a ramp here, and let's put this in the alternative input, and let's put this here, and let's go to the ramp and set this to, I don't know, this gradient, I guess. Why not? Because we can. And again, we have this delay. I have the suspicion that if I wait for a few seconds, it's going to do the update by itself, and all my turning off and on and doing all those things is just me, finding a fallacious pattern, a wrong pattern, and just thinking that if I repeat it, it will happen. So we saw this update. Yep. So yeah, it was wrong for my part. But look at that. Now we are shading the spline using this gradient. Now, the great thing about this is that you can change the size of the gradient. So if I go to 120 radius, you will see that we're going to see less of this dense blue, and we're going to get that lighter blue here. So let's go 120 and press enter and wait for the updates to happen and all that nice stuff. I have an RTX 5000 with 16 gigs of RAM, but this is still 1.1 million splines. There you go. So now there you go. The tips are blue. So that's one way to do it. You can remap this. So by moving these around, you can control how much of the gradient you are going to have. So let me just turn this off now. Let's remove a bunch of these. So let me just remove these. Let me put this here. I'm going to remove this. I'm going to remove this. I'm going to put the green in the middle. All right. So what we're going to do now is I'm going to make sure. So remember, the left is the center. I'm going to have a lot of yellows over here. Then I'm going to have some green. And let's say I want a blue. And at the end, so blue, there you go. And at the end, I'm going to have some of this and then that. So if I turn this on, after it does its little business, we are going to see yellow for a big part of this. Then some of them, as they grow, they're going to be green, then blue, and the tips over here are probably going to be magenta, purple, or whatnot. So let's give it a couple of seconds. Let's not rush it. I'm drinking some coffee. Nice. If anyone watches Curb Your Enthusiasm, they may get the reference to. No. Okay, come on. Thing too long. Press this. I need to do my repetitive patterns here because, yeah. Do that. Come on. Come on. Oh, come on. Just taking its time. And by the way, I'm going to check my resources. It's good sometimes to go to your task manager and check out the actual GPU. Now, this is not uncommon. When RedShift renders, it always consumes all available GPU. Oops. Nope. Is it going to go now? There you go. So it needs to do its own thing. But yeah, as I think I predicted, the yellow, then green, depending on how far away from the center each and every one of these render hit points is. So you will see that radial gradient a bit better over here. Now, that is one thing you can do. Now, a few additional things that will help you manipulate this. So let me bring this. Oh, it was over there. So let's assume I want to move my gradient. Okay, let me get rid of this. So I want to, come on, delete. Let me turn this off. Come on, delete. Right, let me change context, click in the object manager, select it, delete. Yeah, sometimes if your node editor refuses to do what you want it to do, just switch context. So go to the object manager, click on something and come back, and it will potentially work. So let's assume I want to get this gradient and move it in one of the axes. Well, this is something that has to do with the ray position, right? So what you need to do here is when you read a specific position, don't read the position itself, read a position which is offset of the center of the world by a certain distance. So I'm going to just rotate this around here. There you go. So the X is that way. And what I'm going to do is I'm going to do an add, and I'm going to vector add. I'm going to take the original position, which is the distance of each render hit point from the center, and I can go and add any value I want. So let me start the render and wait for it to do its little delaying. It likes doing that. It likes delaying stuff. So again, first we need to see that. Let's do now. I was going to cut these out from the end of the video, but I would like you to suffer with me, as all good people do. And you're all good people, so let's just wait for the data to be uploaded. Yeah, next time, please remind me to do this using fewer than 1.1 million. There you go. Good. So now if I go to the vector add and say, let's move this by, let's say 50, you're going to see the gradient is going to shift on the x-axis. Now, is it going to shift that way? Where's the positive x? That's a positive x. So I added 50 to the x, so the black point is going to move this way over here. That at least that's the theory of it, which yeah, might as well. No, it went the other way because they're further away. Anyhow, you can go the opposite way, whatever. And you can see here that we managed to transpose this. Now, in order to create, and I'm not going to show you exactly how to do this, but the idea is that if you isolate from these vectors, if you split, so split the color splitter, and from the ray position, which is basically a color, you get either the R, the G, or the B, or something like that. You can put it after the vector length of the change range. You can actually create linear gradients just by using one of them. So the permutations of this, you know, there are quite a few. Now, the last thing is, do we have a sample noise here? I'm not sure we do. I was under the impression that we could have a sample noise where it samples the position in space and creates a noise. Let's see if I sample. No, we don't have a sample noise. Anyhow, that's a different story because that something like that may allow you to do noises based on the positions, but that could work with the noise anyway. So that's all I have for this little half an hour video. I hope you find it useful to be able to create quasi, let's say, fields for colorizing your splines. And please post any questions if you have. Well, thank you very much.